Hey everyone, welcome back to the 443 Security Simplified. I'm your host, Mark the Liberty, and joining me today is...
Corey, the truck war driver, Knockreiner.
Oh man, that's actually a good one. On today's episode, as opposed to all your other ones, which are awful, on today's episode, we will be discussing 3 separate vulnerabilities. One of them...
Oh, look at that fancy European 3 you did there. The whole 3. I'm American.
Didn't even
I
notice
just do it that way.
Also, I'm just traumatized from Mac always putting stuff up.
Oh yeah, that's true. And by the way, for all the audio listeners, we're sorry. There's a video version too where you can see what the heck we're talking about.
Yep. Anyways, on today's episode, we'll be discussing a vulnerability that is unpatchable on Macs, speaking of the devil. Then a way to potentially unlock everyone's hotel doors. And then finally, ending with a trucking worm. With that, let's go ahead and roll our way in.
And after, you're going to take a nap in your hotel room when someone unlocks your door.
That's why the deadbolts are so. So let's start this week with the first of 3 vulnerabilities that we're going to go over. And this first one, I guess we're starting out with the most technical one, which may have not been the best way to do this. But anyways, let's get ready to nerd out.
Yeah, and I assume I'm going to get made fun of too, because I happen to use these devices. So
in this particular scenario, I do as well.
You do as well.
So I can't throw shade without catching some of it in the face too.
Just a phone.
Correct. So last week, researchers at a whole bunch of universities, I think it was UT Austin, Georgia Tech, UC Berkeley, University of Washington, and Carnegie Mellon University, all published a white paper describing a new side channel attack vulnerability in Apple's M series processors, which they even gave it a cool little marketing name called Go Fetch. And they even registered gofetch.fail, the domain, to host all of the information on this. Pause there for a second, Corey. How much do you love the big marketing push behind this particular vulnerability before we dive into it?
Go Fetch is cute. There's actually a icon that goes with it. I think you might see it if we share our screen. But they have a cute little marketing diagram that kind of reminds me of my dog. I mean, normally we kind of scoff
like your dog.
At these marketing names. I will say, if it's a big industry-wide, what was the first one? Was OpenSSL, wasn't it? Yeah, I mean, or that was that SSL or was that the Wi-Fi?
It was OpenSSL, no, SSL in general. SSL
general.
2.0, 3.0, yeah.
Yeah, and if it's a huge industry-wide affecting all kinds of software and components vulnerabilities, I get the effort of making a marketing name and you're kind of advertising to the industry that you have to do something about this in the future. So in some cases, I don't totally hate the fact that they give something a name. And this kind of is a big enough deal that maybe it qualifies, although Go Fetch, without knowing more about the technical details, it sounds kind of hokey. And even if it's a cute dog, man, I guess I'll go see if Callie, my dog, will go fetch me some AWS secret keys so I can break into some networks.
Maybe we can get your dog to fetch us some MacBooks. That would probably be even more profitable.
Yeah, ones that don't have this chip problem that we're about to learn about.
As we just hinted at, this vulnerability targets a feature in Apple's M series processors called data memory dependent prefetchers, or DMPs. Which is basically how they use that within the CPU cache memory. And so I guess before we dive into the meat and bones of this vulnerability, there are a handful of pretty technical things I think we need to go through first. I guess first we should start with CPU cache memory, and I guess specifically how it works on Apple processors. So Apple M series processors, so the Apple Silicon ARM-based processors, have 2 sets of cores to start with. They've got what they call, balloons, performance cores and efficiency cores. Basically, if you're doing a task that requires a lot of compute processing, it's going to put it on the performance cores. Otherwise, if you're doing something that isn't maybe as intensive and you're trying to save battery, you can use the efficiency cores. So all modern CPUs come with what's called cache memory. It's located physically very close to the CPU to reduce latency compared to the normal system RAM, which, even by being a couple of inches away, with the speed of light as fast as it is, it still introduces a decent amount of latency as it goes to retrieve data from it. On the M series processors, they have L1 and L2 cache, so two different levels. L1 is 128 kilobytes for each individual Firestorm core, so each of their performance cores. And then all four cores share a level 2 cache of 12 megabytes. And the last important feature for this is that level 2 cache is inclusive of the level 1 cache, meaning every line that's in level 1 is also in level 2 somewhere. Finally, with processor cache, all programs share the same cache, and the CPU hardware itself and its processor code, or whatever you call it, takes care of constantly flushing and reloading automatically what it thinks it needs there to get to quickly. Corey, before we dive further into this, anything you wanted to add to that? Couldn't tell if you
No, I
want to
think
cough
that's
or add something.
a good high level explanation for sure.
All right.
Complicated stuff. But
So,
on chip memory, two caches, and the second cache shares the same contents for some of it.
as you might suspect, your computer wants to have whatever data it's about to need somewhere in cache because it's significantly quicker to access it as it's running through the execution of whatever your program is. And modern computers kind of cheat at that. So instead of waiting until the next instruction, figuring out what memory locations it needs to read from, going and grabbing that out of RAM, loading it into cache, then reading it from there, it actually tries to predict what it might need sometime in the future. So in modern
And by the
computers,
way, if we pause here, this is not unsimilar from the Intel chip flaws before, in that those were speculative calculations. I do think it's fascinating that we're at the point of microprocessor of computer chips where they need to be so fast and they have memory so ready to be loaded in CPU so ready to do things, that rather than wait for the actual thing, half the time they're predicting and starting on what they think is going to come next before it actually happens. So I know this is a different flaw technically, but it's just interesting to me that it's predictive in the way that speculative Intel issue was.
and this is where the bulk of like modern computer processing power, like improvements, have come from. It's not just like slamming more transistors into these chips now. It's like adding these entire new features and capabilities to help speed it up and lower
Predict.
latency
Yeah.
predictively.
So we've been
So
hitting the physics limits of Moore's law. We can't squeeze much more in as quickly as we did transistor wise. So it's funny how we're using tricks and statistics to get
yeah.
our speed increases now. I assume
So
it's
in the world of,
statistics that helps it pre-calculate and predict what might happen next.
I'm not even going to pretend to understand like the math that goes behind all of this like CPU hardware design. But so one of these predictive features is called a prefetcher, where basically the hardware is designed to try and lower latency, where it'll retrieve something because normally retrieving something from RAM it might take 300 milliseconds, actually way the heck less than that most likely, but some order of time, whereas retrieving it from cache is way quicker. And if you go to retrieve that data from RAM, the process execution has to wait until that data returns, and that wait is going to be like hundreds of CPU cycles potentially, where it's basically just wasted time. And so instead of sitting there waiting for data to return, the CPU tries to guess what data it might need and it prefetches it, loading it into that level 2 cache from RAM or into level 1 cache from level 2. In Apple, and I guess a few others, Intel as well, on their latest 13th generation processors, have a special type of prefetchers called data memory dependent prefetchers, or DMPs, where it's a special class of them where it will actually read the memory, so the data that the program is using, to look for things that it might want to prefetch. So, for example, it might look through the memory that this process or program is using and look for things that look like memory pointers, basically addresses for where other data might live somewhere in RAM. And it will automatically load those pointer addresses into memory and then try and dereference them. So dereferencing is going and grabbing the data that may or may not exist at that particular pointer location. So now it's not just looking at the code that's running, but the like actual data it's pulling in as it's executing, looking for things that look like memory addresses, and then preemptively trying to go and grab data that might be in there that it might find useful at some point in the future. These are the lengths that these processors are using to try and speed up latency and just grab anything it might need at some point in the future.
Yeah. If they
Um,
did nothing, it was for sure wasted work. But if they're smart on their prediction, they might get a head start on something that's about to come.
exactly. So this whole like all these time and latency saving features open up a suite of vulnerabilities, and you already mentioned the meltdown inspector speculative execution issues. Where if you remember, for those vulnerabilities, code typically has a whole bunch of like if or like branching statements, and the program doesn't know the result of that until it does the calculation, but it can, using speculative execution, go ahead and grab both potential results and be ready to go depending on which one ends up being the winner. And that opened up a suite of side channel attacks against Intel based, and I guess really all processors at that point several years ago. So in this particular class of vulnerability, a cache side channel attack, the attacker tries to infer something from a victim program, so the memory that some other program running on the computer is using, tries to infer what's going on in that memory by observing the side effects of that victim program's access to the processor cache. So it typically works by bringing the cache into a known state, like it'll write a whole bunch of stuff to the cache to kind of reset it, then letting the victim program execute, and then checking the state of the cache to learn information about the execution. And depending on, for example, how quickly you can retrieve data from a memory pointer, you can learn whether that pointer was loaded into cache or not. Because if it was in cache, it'd be quicker than if it was not in cache. And that can leak information about the program execution. At a high level for this specific vulnerability, they use what's called a chosen input attack against a cryptographic function. So this could be like, I don't know, the OpenSSL library that is being used to encrypt and decrypt web traffic to a web server. Or on your Mac, it could be something being used to sign cryptographically sign an application. Basically, anything using cryptography to encrypt, decrypt, or digitally sign. It uses a chosen input attack where they choose something to be run through that program that manipulates the data that's inside that encryption algorithm to ultimately make it look like a pointer. So make it look like a memory address. DMP, that prefetcher, then sees that data value and thinks, oh, that looks like a pointer. And it goes to load it into cache and then tries dereferencing it. So accessing the data that may or may not exist at that pointer. That dereference, so reading the data at the pointer, actually leaks the address location to other programs that share that cache. So it doesn't leak the contents of the address, like if it was holding a key at that address, but the address itself is now known to anyone else using the cache. And then their malicious program basically tests memory locations using a timing attack here to suss out potential memory pointers that are really derived from the cryptographic key being used in this program. So that's like the 10,000 foot level, and even then that felt like highly technical.
Yeah, it's definitely complex to know, but at the end of the day, it's the dereference is allowing a little bit of memory from other programs sharing a cache to leak, and if there's something sensitive going on in that cache that's being shared, that leak could be a big deal, as I'm sure
So
we'll find out.
if I took it to like the 30,000 foot level, we could say it basically tricks the program you're trying to target into loading its key as a memory address, which then gets cached, which is then readable by that other malicious program. Now there's a bit of funky stuff going around behind the scenes that they have to basically derive the actual key, but that's effectively what it's doing.
I'm sure a
So
lot of timing, there's a lot going on in that timing attack. I'm sure they don't always get the right data they want, and it takes a while to, although a while might be only a few minutes, but yeah,
well,
these
in
are
this case, it does
complicated.
actually takes a decent
Happen in
amount of time.
seconds. Okay.
No, more than minutes though. So first off, though,
Oh,
the
there's a
attack doesn't.
video I watched. I didn't really know if it was real time, and the video is about 3 minutes long.
So yeah, it's dependent on the key. So the video that they had on their website for the proof of concept is a very small key. But for like a practical attack against modern cryptography, so for example, a 2048-bit RSA key or a 2048-bit Diffie-Hellman key, it takes less than an hour or so for an RSA key and a little over 2 hours to extract a Diffie-Hellman key. So not
So
like,
it does take time.
years, but still like, if it's malware running on a Mac-based computer, it's still something that could happen. Like my laptop is unlocked for more than an hour, and it could potentially allow someone to extract secret keys out of my MacBook.
Though I guess 2 hours is in the realm of reason. If you had something that detected the unusual activity that the malware would have to do, you might be able to stop it before it finished. But anyways, keep
I would
going.
hope so.
This is fascinating.
Yeah. The attack, because of how it works, doesn't require root access. Any user program can run and potentially extract keys from other sensitive workloads on the computer. And it basically works by feeding data to another program that either signs or decrypts that data and then steals the key that was used in that operation. But so the big takeaway from this, and the thing that grabbed all the news headlines last week, was so DMP, this prefetcher, it's a hardware feature and it cannot be patched by software, meaning it is effectively unpatchable on certain Mac based systems, which is, it's a pretty big deal. It's a unmitigatable vulnerability in this case, at least from the hardware level. There are some mitigations that you can, like the applications can use themselves. So, for example, there's this concept of constant time programming, which is basically where you write your application very carefully so that the code is resistant to timing based attacks. There's also another mitigation they came up with called ciphertext blinding, basically adding or removing a mask to sensitive data values before you go read or retrieve them from memory, which they said, long story short, basically randomizes the state of the cryptographic algorithm, making it almost impossible for the attacker to control it and exploit it. But that comes at a pretty strong resource cost, basically using double the resources, which in the world of computing, you're trying to make your computer program as like lean and lack of resources required as possible. So doubling the amount is a pretty big deal. Last bit though, so the M3 processor, the latest evolution of Mac's processors, does actually have a special bit that developers can set to disable DMP,
Hmm.
but with a performance optimization hit on
Yeah.
those machines.
Same thing
Uh,
we discussed with speculative execution. Even if you turn it off, you're literally kind of hobbling your processor to the generation before that didn't have the capability. So,
yeah,
but at least
and
it is nice that the M3 can disable it for very secure organizations or workloads or whatever, or
And so one of the things that the researchers
devices.
pointed out, like a nice thing to have, would be the ability to selectively disable DMP on like specifically like security critical tasks. So like when you go to read a cryptographic key or use that key within the program, disable DMP then, but still allow it for the rest of the program to run to gain that efficiency boost.
That would have to
Um,
be like a new hardware update, though, like an M4 that not only has the disable bit, but has like a software enabled one where certain software that had maybe its own signing key saying it was security related could do it well. That would be cool, though. I mean, that feels
yeah.
like the best compromise of making sure you're secure, lose a little bit of efficiency for security processes, but keep it fast for everything else.
Yeah, but the main takeaway from this, though, it feels like we're in an era of computing now where, Intel and AMD and Apple, they're running up against a wall of, like you said, like how much actual transistors you can cram into a chip. Like we're down to what, 3 nanometer manufacturing in some cases, which is just insanely small. And it's difficult to make more headway from there. And so they're relying on these other kind of cheating techniques in order to squeeze out as much computation power and efficiency as they can. But they do seem to be coming with some security concerns. And I think like one of the biggest issues is that oftentimes these new tools and these new methods are pretty opaque. Like the manufacturers aren't exactly like spilling the beans on how a lot of these kind of cheating, speculative execution things work. And so it can be
Well, it's
difficult
kind of
to
IP.
find
I mean,
issues.
I get
Yep.
it. I mean, if this is what's giving their brand processor a little bit of speed advantage, But to your point, I mean that we always argue about open gardens versus closed gardens, open source versus proprietary source, and the downside to any sort of IP that you're trying to hide is you're also not getting the benefit of a community finding all the issues with it that you might need to fix.
Yep. So, what do you think, Corey, on practical impact for this one? It is technically an unpatchable vulnerability in Apple hardware, but what do you think the actual risk is?
Well, I don't know whether what do you really do about it. I would hope for these type of very complicated attacks, you hope that they're not going to be exploited widely. These researchers, I mean, I haven't looked at any of their papers, but it depends on how easy a program is that someone releases that can actually leak a key. But to your point, I mean, I think the key is what you said. For really long keys, it could take 1 to 2 hours. I presume it wouldn't be that hard for some sort of endpoint product to try to look at processes that were doing the weird things associated with what they'd have to continually grab bits of memory using this process. And maybe we could have software that at least detects it and kills that process before it
Yep.
completes. But I don't know. Do you think it's it all depends on what the researchers released. I always think these vulnerabilities seem hard, and only the people that figured out how to exploit them are capable of writing the programs that grab all this data. But they
So I
sometimes
think
publish their research.
like if we look back to Spectre and Meltdown, that was a big deal because it could be used to break out of a like virtual sandbox. So on shared hardware like in cloud computing where your environment is running alongside other environments on the same hardware, Spectre and Meltdown could be used to break out and potentially read information from other
All of it.
programs.
Yeah.
In this specific vulnerability, you can only target other programs that you are capable of interacting with. So it's not like a sandbox escape for virtual machines. It's
Yeah.
more impacting just a local machine. And I mean, while this is a potentially useful way to steal sensitive information off a machine, I have to imagine that once you've already gained local access to like a MacBook,
Oh, that's true.
like
Yeah.
you're going to have other ways to elevate your privileges and steal secrets however you want, just using the underlying operating system and the applications running on
That's
it.
an excellent point. Yeah, you have malware running on the system already in order to do this. Granted, low
Exactly.
privileged, but still.
So I think it might be another tool for attackers, but in terms of like practical impact, I don't think this is anywhere near as Spectre, Meltdown, and the rest of the other ones that came out over the years after that. But still potentially a useful tool for cyber criminals on MacBooks.
Still fascinating. And when a while ago, we arrived at an age where compiled source code vulnerabilities seem to be, or classes of vulnerabilities seem to all be discovered. We all know memory corruption flaws, the many variants. There wasn't much new coming out. So it's just interesting to see this new layer of research where we're finding hardware CPU level flaws. And I do still find it fascinating that all these flaws so far seem to be in predictive elements that are meant to speed them up. So I just think it's kind of neat between Spectre Meltdown and now Go Fetch. Go Fetch does not sound nearly as scary as Spectre and Meltdown. I
No,
will say that Spectre and Meltdown are like, oh shish kebab, this is a big deal. We better do something about it. But Go Fetch is kind of cute. Maybe that's good. Maybe, like you said, it's not as risky, so it has a cute name. But either way,
feels
what I
like
was saying is, oh, go ahead.
James Bond versus Austin Powers on this one.
Yeah, totally, totally. Go Fetch is very Austin Powers. But I do think it's neat that I think maybe in the next decade, where all the new classes of vulnerabilities might be, will be in these kind of CPU features meant to improve our computing speed. So I just think it's interesting that we probably have a fascinating area of research for all the latest new security nerds in academia.
And especially
I
like with
hope they're the ones that find it, not the state sponsored threat actors.
yeah, but it's specifically with Apple hardware though, because the M series processors are still relatively new. Like, yeah, they're based off ARM, which is a
Well
established
known.
architecture
Yeah.
for quite some time that they're licensing. But they're still new hardware, and Apple is adding new features like this. I feel like
Yeah.
it is a new frontier for finding these style of like really in the weeds hardware vulnerabilities, and this probably won't be the last one that we hear about. in the next couple of
No.
years.
On the positive, though, being that Apple has full control of this and they don't have to have a third party
For
like
now.
Microsoft would, yeah, they're getting the antitrust suit, which maybe they deserve. But they at least can react to them quickly. So I think you're right. It's a new area of research where we'll find things, but I have a feeling Apple will adjust very quickly as this type of research comes
Yep,
out.
I agree. Either
Unless they're
way, really
broken up
cool
into
research.
12 companies and told not to sell mobile phones anymore.
I don't think that we'll get that extreme, but maybe
I'm
we'll at
pretty
least
sure
be allowed to
Apple
put
will.
on our own app store and
Software. Yeah.
games and
We
stuff.
can
Yep.
sideload and make our iPhones less safe.
Perfect. It's what we wanted, just like Android. So moving on to the second vulnerability we're going to chat about this week. So this was discovered or disclosed last week by several researchers, and they called this vulnerability un-patchable, specifically because it is a vulnerability that can allow attackers to unlock RFID door locks commonly used at hotels that are of the model called SafLock, which is sold by a Swiss lock company called Dormakaba. Man, those are some fun words. I imagine they mean something a little bit differently in like Swiss than in English, but anyways. So these door locks, though, they're currently installed on 3 million doors worldwide and 13,000 properties in 131 different countries. You've probably seen one if you've traveled anywhere in Europe. I know I have, especially when they describe what they look like. I can picture that thing anywhere. It's a little circle with a couple of wavy lines through it, kind of like ocean waves. Um, Anyways, so it exploits a weakness in their encryption and the underlying RFID system, which is known as MyFair Classic, which is actually a RFID system that has a few of its own vulnerabilities that have been discovered over time. As a prerequisite to this attack, though, an attacker does need a keycard from the hotel. That said, an expired keycard works fine, so you can go fish one out of the garbage or maybe just go stay there for a night on your own. Basically, you need a keycard to be able to get the hotel's unique identifier off of it. And then once you have that identifier, using an RFID read write device or just a flipper zero, for example, they found that they can open the door to any room in the hotel using just two keycard taps. The first tap rewrites a piece of the lock's data, and then the second tap opens the lock. They weren't giving out a whole bunch of details on this because the fix is still being rolled out. But at a high level, they pointed to a couple of vulnerabilities. So one was a issue that let them write to the underlying system, and then the second vulnerability was something that allowed them to know what to write to the system. They found these by basically getting a hold of this RFID door lock system off of like eBay, effectively, and then cracking Dormakaba's encryption system and the key derivation function that was used to program sequential keys at a hotel. So they originally shared this vulnerability with Dormakaba back in October of 2022. They noted they've had 13 meetings with them over the last year and a half, and the fix
By the way,
started
that
rolling
that
out in November.
is it, the researchers don't seem to be upset about this because I think they did a really responsible disclosure by even letting hotels have time to upgrade. But I think it's pretty amazing that this is a research timeline that extends from 2022 up to 2024. It's a
Yeah,
long period.
but it seems like based off their timeline, it sounds like Dormakaba was actively working on
Yeah.
potential fixes and working with the researchers on it, which is great.
Normally that's like normally the if a researcher is complaining about that long time period, it's kind of to show the negligence of the vendor. That is clearly does not seem to be the case. Even though it's a long timeline, they say there were 13 meetings, so it seems like it was a good uh, responsible relationship between both. And the fact that 11 2023 November 2023, they mentioned first hotels upgraded to resolve the vulnerability. These researchers didn't just wait for them to fix software, they waited for them to actually update hotels and get which is in this kind of flaw is a very good thing because day
Yeah.
one you could leave a lot of hotel guests in the lurch.
And so the fix, it requires updating the hotel's central like software system for this. and then sending out a tech to just reprogram each door one by one by tapping it. Only 36% of locks worldwide have been updated so far, which is still, I'd argue, from November of last year till now, it's a decent chunk
Yeah, that's a
considering
lot.
the industry. But
That
so
may
you
have
mentioned,
more to do with the hotels and their speed than the company and the
correct.
researcher.
So you mentioned something interesting here, where it seems like they're being very metered about this approach because of the potential seriousness of the issue. And this is actually in stark contrast to a Black Hat 2012 presentation, where some researchers back then ended up giving a presentation on similar flaws in locks made by Onity, which had an installation base of 10 million at the time,
Oh God.
specifically because the company refused to pay for hardware upgrades necessary to solve the problems, and instead put all the burden on its customers to mitigate these vulnerabilities themselves with the additional cost. And so the researchers went ahead to Black Hat and said, all right, here's how to exploit the vulnerability. And within months, actually a couple of years, not months, there was actually a string of hotel robberies that occurred by exploiting this vulnerability to break into rooms and steal everyone's belongings out of it. So this is a very different situation here where the vendor has proactively worked with them, identified a fix, and has started rolling it out. And because of that, the researchers have held off on any of the in-depth details and only released this high-level description of it like a year and a half after finding the vulnerability.
This is kind of a soapbox, but I think this is why, and I think you and I agree why it's also a good thing that the U.S. government is doing Pillar 3 of their White House cybersecurity strategy and trying to put some liability on the vendor. Because I think we both agree that the way SafLock is doing things as a company, you have a vulnerability. It's not great, but it's everybody has issues in code sometimes. SafLock seems to be do the right thing, fix it, and works with customers to get it fixed. That is taking some liability for your vulnerabilities. Whereas to your point, that other company doesn't even, it's not worth my time to remember its name. Uh, that's why the government has to regulate this because they're offsetting that liability when they are at fault. You know, I get we can't take liability for everything as a vendor. There's mistakes on both sides, but you got to take ownership of the problems you induce. So yeah, that is an interesting story
Especially
about
in
the
like
polar
this
opposite.
specific situation where it's a lock to a door in a hotel.
Yeah,
Like
and it's
that's
not just the theft. I mean, lives are at risk. There's a person there too that could be under threat if you unlock a door. Anyways,
So if you are concerned, you want to make sure like if you show up to your hotel like I just did today and you see a little circle with squiggly lines on it, you want to make sure that you're safe from this vulnerability. You can check your lock by using a NFC reader app on your phone, scanning your room keycard, checking if it was manufactured by Dormakaba, and if the keycard still says that it's a MIFARE, so MIFARE classic card, then it is potentially / likely vulnerable. Otherwise, you are most likely safe from this particular attack. But
but it won't
either
help
way,
you when you leave your room. But the other just practical tip is hotels do have that interior lock that I used to think like what's I don't really need that, do I? But it's probably good to slap on that little interior lock so at least when you're in your room, if someone does unlock your door, they still can't open it.
yeah, highly recommend using the deadbolt in your hotel room for a multitude of reasons, not just because your key card could potentially be unlocked by a hacker with a flipper zero. Either way,
Needs can come in
the
at the inappropriate time.
yes, exactly.
That's never happened to
They
anybody ever.
they are at least rolling out the fix, and so hopefully, you know, I can't imagine the hospitality business is super quick on upticking this type of resolution, but maybe by this time next year, all of them will be patched. We shall see. That said, let's move on to our third story, and this one's a pretty fun one. So this one came from research students at the Colorado State University, which they just presented earlier in March at the 2024 Network and Distributed System Security Symposium in San Diego. So the vulnerability they were presenting on was in the electronic logging devices, or ELDs, that are present in around 14 million commercial trucks. So in the United States, this is a required system for logging like driving hours, vehicle movement, distance traveled, other statistics to try and make sure that truck drivers aren't effectively driving too long without brakes. And they didn't mention any specific brand, but they did note that there's not a lot of diversity in this space, with only tens of devices out there that most truck drivers are potentially using. So, for the vulnerability, these ELD devices, the electronic logging devices, in order to get their statistics and information and interact with the truck, they connect over the truck's CAN bus to communicate with the different systems. And it's not just a read only communication, they can actually write to and interact back with some of the systems within the truck. And unfortunately, as you might suspect with some of these IoT-ish devices, there's several weaknesses in how they're actually deployed and managed on these trucks. So first off, the first weakness is the ones they were targeting exposed a API that permits over-the-air updates of the firmware for the device itself. Second, the Wi-Fi and Bluetooth networks on these devices were enabled by default. And then third, and most egregious, the Bluetooth identifier and Wi-Fi SSID are both easily identifiable and easy to predict, and they typically come with a weak default password. So they found that you can connect to these devices using the vehicle or using the exposed Wi-Fi or Bluetooth network with the default credentials, which then let you interact directly with the vehicle systems as long as you're within wireless range. And as you and I have talked about, like wireless range doesn't even have to be normal wireless range for like a laptop. You can hook up a antenna the size of a Pringle can and potentially snipe these devices from across a football field if you wanted to. So
Can we pause on
yeah,
that here just to talk about of those three things? Obviously, the default password on the Bluetooth and Wi-Fi is the most egregious, and even having that by default is bad. I am mixed on saying that exposing an API that permits over-the-air updates as being entirely bad. It depends. Like what I'm getting at is for cars and for IoT devices, I actually think over-the-air updates are a strong security feature because I think just like cellular phones and the wireless, I mean, people can't force us to update the OS of our phone, but our phones have over the updates for the wireless chips if there were a big vulnerability. I think manufacturers have to have the ability to force over the air updates to car-like devices for critical security flaws. The issue is the how exposed part. I mean, just because it has an API doesn't mean it shouldn't still need a key to update or some sort of authentication and encryption. So I want to learn more about why they think maybe it's the API is exposed and too easy to access for anyone. But I think having over their updates itself shouldn't be considered a weakness. It should only be
I think
weak
that
if it's
is
easy to do.
specifically it, that it's unauthenticated and with no integrity checking,
Yeah,
and that it's
in that
available to
case, it's
anyone
obviously
wirelessly.
stupid beyond belief.
Yes.
You should allow over-the-air updates, but by definition, should be secured by only the vendor being able to force over-the-air updates to whatever device
Yep.
they are the creator of.
So they gave three different attack scenarios. And the first one was you could connect to the wireless radios and send arbitrary CAN messages that could disrupt some systems within that vehicle. The second one was where an attacker could upload a malicious firmware and manipulate data on the vehicle. And the final scenario is the most fun one, where they developed a trucking worm, where basically it uses a compromised Wi Fi capable device to search for nearby vulnerable ELDs and infects them by first searching for SSIDs that start with a certain pattern, connecting using the known default credentials, using that OTA feature to update the firmware, which then starts the process over and looks for additional vulnerable devices.
I mean,
And
it's not a radio station, Mark, but it's pretty much your favorite GTA video game hack in real life.
it is, yeah. So in the demo, they showed it on like an empty airstrip using a 2014 truck and a Tesla Model Y. They were both driving at 20 miles an hour. There was a
War
laptop with a
Teslas.
larger wireless adapter connected to it in the Tesla. And they found that it only took 14 seconds to connect and reflash the vulnerable ELD, which then would allow it to spread that worm to anyone else that drove by. And I don't know, Corey, I just drove from Kansas City, Missouri to Manhattan, Kansas, so about 2 hours on a very straight and narrow road. And I passed a lot of trucks that were driving side by side, slowly passing each other for way longer than 14 seconds. So I
Next
feel
time
like
you
this would
get
be
boxed in by trucks, you can get your revenge by hacking them with your wireless over-the-air worm.
shut down their engines to let me pass because they're eating up the left lane in their stupid truck going a half a mile an hour faster than the one in the right lane. Yeah, I'm not annoyed at all by that. But what I'm getting at is, like, you can imagine one of these gets infected, driving across middle America, slowly passes another one, infects that guy, and, within a week, suddenly you've got a zombie running across all trucks in the United
I hate
States.
the fact that I think this is cool too. I mean, this is scary as we can come up with how the world is ending, but it's pretty damn cool. It's a good
You,
hack. I'm glad the good
you
guys
know,
found it first.
the whole concept of one of my favorite TV shows, at least the reboot for it, Battlestar Galactica, was that the Battlestar Galactica survived because it was the only one not connected to the network. It's feeling
Cut
like
the
a lot of
wires.
our like stuff like this, maybe we should not be connecting them to the network. And
Cut
this is
the
a
web.
great example of stuff like that.
We need to air gap everything.
Exactly. And I guess in the very minor, small defense, it's not like these are intentionally connecting to a mesh network with each other, but an easily guessed Wi-Fi SSID and a default password that no trucker is ever going to change is opens up a pretty
I
big
do want to
area
meet the
for.
trucker that does, because I'm sure they've customized they're probably a pretty cool tech. Who knows? Truckers may be super nerds. I bet they are.
I mean, nerd is a umbrella term for many things, and I bet they could probably
Yeah,
nerd out on trucking and
trucks for
pimping out their
sure.
truck. But yeah, I can't imagine many cybersecurity professionals turn to truckers. But that said, the job market
You
right now
never
is a bit
know.
sketchy, so who knows?
There is burnout. That's where the
Yeah,
50% of CISOs who are leaving, they're like trucking,
screw
less
it. I'm
stress.
going to be a trucker.
I could drive with podcasts. No one's going to try to put me in jail.
But I mean, as much as we're joking, like this, what one of our critical infrastructure sectors that CISA is in charge of is
It is.
transportation and food supply, and like this
I
all
say this all
falls
the
under the
time, but like
umbrella.
Vegas can't exist, I hear, after 24 hours. I mean, trucking is really their primary lifeblood for food and to some extent water. So, trucking is definitely critical infrastructure, especially in certain parts of the United States.
And if you could just create a worm to effectively disable trucking at some point in the future, like that would be a pretty dang powerful attack. So this is a
I guess
serious
my only
issue that.
complaint is why are we giving Russia and China ideas? I guess China we don't. They already own us financially, so they don't need to cyber attack us. But
Fair. I don't know. Maybe this is one of those cases where the FBI can like preventively like close the gap by intentionally sending out an FBI crafted worm to patch
that
all of these
patches it. Yeah, there
ELDs.
we go. That would be cool. Preemptively
Man,
disable the truck to truck botnet.
we say cool, but there is a pretty icky gray area if they haven't been
Yeah.
proven to be a victim of a crime yet. Either
uh,
way, this is our
Fun
future now.
times
Maybe
we
we
live
don't.
in.
Yeah, we
Yay,
don't have to worry about
technology.
AI taking over. Now we just have to worry about trucking worms.
Truck worms. I'm still trying to cling to technology will help humanity. Stop trying to break my hope.
Like I said, I am not convinced that it's
It's
not the polar
net
opposite.
good. Net good. I
I
try to
think we are.
convince myself.
We're all screwed.
And with that,
The end. Hey everyone, thanks again for listening. As always, if you enjoyed today's episode, don't forget to rate, review, and subscribe. If you have any questions on today's episode or suggestions for future episodes, you can
both
reach out to
send
us
us
on.
questions. Just talk to us. We're kind of lonely, man. We'll even use Twitter. We won't call it X, but we'll even use Twitter.
That said, reach out to us on Instagram at WatchGuard_technologies. another social media platform that I will most likely never use. But we will still hear what you send to us thanks to our producer. So please talk to us. Anyways, thanks again for listening, and you will hear from us next week.
Rock on.
It's so dumb.
And that's why I do it.